Okay, so you need a little help with your homework. We're going to go over a couple of examples. Number one, I've drawn my T-chart here. I've labeled my inputs. I started with the standard ones, and I've gone with the larger form of the chart to show you that all I'm doing is replacing both x values, the x squared and the one that's next to the negative 6, with negative 2. I'm going to square the negative 2, multiply negative 6 times negative 2 and add 8. I'm going to repeat that process for negative 1, plugging negative 1 in both locations. I'm going to just basically tell you you're going to continue to do this process all the way down just like we did it in class. And you can use this for any type of equation that you want to graph. So our outputs for negative 2 are 24, and our output for negative 1 is 15. And they're incredibly huge numbers. They're not going to fit in your tiny graph, although we did talk about earlier today that there is one like that. Instead, what you really want to do is you want to start off with x is equal to negative b over 2a, the formula for your axis of symmetry. Plug in your opposite of b, just like we did with the quadratic formula. So in this case, it'll be positive 6. And put that over 2 times a, or 2 times 1, which is just 2. Again, this is your equation for your axis of symmetry, or your line of symmetry. X is equal to 3. It is a vertical line that passes through the x value 3 and cuts the graph perfectly in half. We're going to go ahead and use the table anyway in our calculator. So here's a chart where we want to use putting 3 right there in the middle and using 2 values to the left, 2 and 1, and 2 values to the right, 4 and 5, giving us the following chart. Go ahead and plot your points down there. And then also record on your homework sheet the formula for the axis of symmetry, which again, x is equal to 3, and your coordinate x and y points for your vertex. Your input was 3, your output was negative 1, so that is your vertex 3, negative 1. Let me fix this here real quick. And there it is right there in the middle of your T-chart. There we go. 3, negative 1. Okay, so let's look at number 3, which a couple of you asked about. This one does have big numbers. If you go ahead and put it into your table, you're not rating it incorrectly, just go ahead and change the values of the y-axis. As a reminder, when we're talking about a, b, and c, we're still talking about y equals ax squared plus bx plus c. That is your standard form for your quadratic. You should always just start off with all these, labeling what a is, what b is, and what c is. Again, we're going to go ahead and start off with our axis of symmetry formula, where x is equal to negative b over 2a, and again, negative b is the same thing as the opposite of b. So opposite of positive 6 is negative 6. Put that all over 2 times negative 1, which is going to give us negative 6 over negative 2. Negative divided by negative is going to give us a positive value, and our axis of symmetry equation is going to be x is equal to positive 3. Go ahead and plot that down, and then you can make your T-chart where 3 is the middle. You choose 2 values to the left, 2 values to the right, and then I can just go ahead and show you real quick. We can finish off the vertex equation by plugging in positive 3 into our 2 values where x is squared and x is multiplied by positive 6, and that's going to give us the y-coordinate of your vertex. So your vertex is going to be positive 3, 2. Or I'm sorry, positive 3, 21. So yeah, those are some big numbers. Please note that a negative a value will flip your entire graph upside down. We're going to get more into the transformations or how the graphs move as compared to the parent graph, but a big thing to remember when you go and plot this is that graph is going to be upside down. So go ahead and change that on your chart. The last one we're going to look at is the bottom two, 9 and 10, which say to solve. Yes, this is the old material. Yes, it will keep coming up. Yes, it's an x squared, which means that you're going to have two different values. I'll go ahead and rewrite our number 10 here, 4x squared minus x plus 7, set it equal to 0, and again I'll label a, b, and c. Remember, we're dealing with ax squared plus bx plus c. So a is 4, b is negative 1, and c is 7. I can do my diamond here, where I've got a times c on the top and b on the bottom. 4 times 7 gives us 28, and b is negative 1. And instead of messing around with that, which probably isn't going to work out, I can go ahead and jump right into the quadratic formula. Negative b, or opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. We dealt with the b squared minus 4ac when we talked about the discriminant. So let's take a look at that real quick and say, okay, opposite of b is going to be, or b squared is going to be negative 1 squared, and then minus 4 times 4 will be negative 16 times 7. That's going to be a negative discriminant, which means we're going to be dealing with imaginary roots. So we definitely have to go ahead and use the quadratic formula, and I'll leave that up to you. One other quick note, check out our negative b over 2a. That's our axis of symmetry formula. So the quadratic equation actually taught us both of those things.